All right, so this week we are going to talk about the outer part of the solar system. Last week we talked about the inner part of the solar system, and you should recognize some things on here. We have the gas giants over on the left here. You can see some Kuiper Belt objects here, including our buddy Pluto here, who unfortunately got kicked out of the Planet Club. You should know that this thing over here is the Kuiper Belt. We've already talked about that, and so we're going to talk about some of these things in more detail. Don't forget about the red slides. Take your notes then. You should have your outer planets handout ready to go, and make sure you look for the owl and tell me where he is. At the end, you'll have to tell me where the owl is and do your little 2 to 3 sentence summary. All right, so let's start talking about the outer planets, also known as the gas giants. And I bet you know some of these guys already. So top left is Jupiter, and then a lot of people's favorites because of the rings, Saturn, and yeah, one of those two, and Neptune. So gas giant. Gas giant is a large, low-density planet composed primarily of hydrogen, helium, and methane in a gas or liquid state. Usually it's a gas towards the outside, but then because of the pressure of all that stuff on top of it, it tends to get kind of squashed towards the center and becomes sort of a liquid, and it may even have a solid core, these outer gas giant planets. We actually don't really know too much about the inner structure of these planets. What we do know, though, is that one characteristic of these planets is that even though they're much bigger than the inner planets, they are actually quite a bit lighter because they're less dense. And of course, that's because of the fact that solids, what the inner planets are mainly made up of, their atoms, their molecules kind of look like this. They're very closely packed together in a solid. In a liquid, they're kind of less packed together, less dense, and in a gas, they're very spread apart. Gases are the least dense state of matter. And so because of that, they're large, but they don't have a lot of mass to them. So if you could somehow weigh these objects, and remember, there really isn't any such thing as weight when you're in space, so this is kind of a weird idea, but if you were to be able to somehow weigh these objects, the inner planets would actually weigh more, even though the outer planets are larger. We can see some of that in this diagram here. We can see that like the diameter, which would be basically the size of Mercury, is 0.38 on this scale. And these are all compared to Earth, basically. You can kind of see how big these things are and how much mass they have in comparison to Earth here. So you can see Mercury is less than half the size of Earth, right? And has a mass of 0.06. So that has a kind of a low mass, but its density is 5.4. So actually pretty similar to Earth's density. We have Venus, which is 0.95% or 95% the size of Earth. And so it's, as you already know, Venus being Earth's sister planet is very similar in size to Earth, similar in mass to Earth, and similar in density to Earth. Very similar planets. Mars we see is about half the size of Earth. And then we get to the outer planets. So Jupiter is about 10, maybe even almost 11 times the size of Earth. But look at its density. Its density is only 1.33. So its density compared to Earth's density is about 1/5 of the density of Earth. Saturn is about 9 times the size of Earth, and it has 0.68, so that's actually close to like 1/10 of the density of Earth. And then you can kind of see the rest of them. You can also see the size of Pluto. Look at the size of Pluto. It's only 0.2 of, compared to Earth, only 2% of the size of Earth, and 0.002 compared to 1 for the Earth's mass. So, interesting kind of thing here is that Saturn's density is the only density that is less than 1, and so Saturn would actually float in water. Again, that's kind of a weird idea to try to say that because you can't really do that exactly, but if you could somehow put Saturn in a bathtub, it would float. All right, so let's get into a little bit more detail of each of these 4 planets, starting with Jupiter. Jupiter, the biggest planet in our solar system. And so what you see here, this is a really cool picture of Jupiter and one of Jupiter's moons over here. And one of the things I like about it is right there you can kind of see the shadow of that moon on Jupiter. That's kind of a cool shot, and you can see all these kind of swirls of gas on. All right, so some facts about Jupiter, the largest planet in our solar system. Well, it really is large. It's twice as massive as all of the other planets combined. So if you were to take all of the other 7 planets and kind of squish them into a ball, they would only be half the size of Jupiter. Jupiter is mostly hydrogen and some helium. A lot of the things in the solar system, the main gases in the solar system, are hydrogen and helium. So you find that a lot of the gassy type of things in the solar system, like stars and gas giant planets and nebulae and things like that, all tend to be made up mostly of hydrogen and helium. That's a good thing to know. Surface features, we have the bands and the Great Red Spot. This is something that you definitely want to know about. These are caused by swirling winds. You can kind of see them all moving around in this picture here, and right there is the Great Red Spot. And one thing to understand about that is that you could fit 3 Earths in that Great Red Spot. So Earth is only about as big as those little drawings that I'm doing there in comparison to Jupiter. Jupiter is gigantic.
The outer solar system, realm of the giant gas planets, is the true home of the superstorm. The planet Jupiter is so vast that more than 1,000 Earths are, a planet that's all atmosphere. As long ago as the 17th century, the astronomer Cassini saw a mysterious dark shape moving on Jupiter's surface. The Great Red Spot turned out to be a type of hurricane, twice the size of the Earth. Now, after more than 300 years, the Great Red Spot is still raging, and it's not alone. The surface of Jupiter is teeming with storms, powered by the sun's heat, but Jupiter only gets a fraction of this energy because it is 5 times further from the sun than we are. Jupiter's weather is driven by a powerful engine deep in its secret interior. The greatest flashes of lightning ever seen were detected on Jupiter by the Galileo spacecraft. Thunderbolts 50 miles across and 100 times brighter than typical lightning flashes. Only Jupiter's outer surface is visible, but its lightning gave us a window into the planet's hidden interior. And when 700 miles of cloud broke its surface, planetary scientists were seeing the same thunderstorms as those on Earth. Scale.
This was extremely exciting because now we had lightning on another planet, and we've actually correlated the lightning with certain types of clouds that you see on Jupiter. In particular, these beautiful bright white plumes that erupt in the low pressure regions on Jupiter.
Jupiter gives out twice as much energy as it receives from the sun, with heat left over from the planet's formation. As it cools, hot gases rise towards the surface, powering thunderstorms as they go.
All right, and Jupiter has something like 63, more than 63 moons. It's a little hard to keep count because there's a lot of them, and some of them get kind of small, and there's not really a good definition there of exactly when we call it a moon and when we just call it kind of an asteroid or something like that. So a little hard to say exactly how many moons, but I'm not real concerned with you knowing the exact number, just that the outer planets tend to have a lot of moons. So if you remember something like 60 or so moons, that's pretty good. And this is kind of a cool little shot here. And you can actually see this little shadow. If you look right about where that arrow is pointing, you can see a shadow of the moon kind of going by, one of Jupiter's moons. So, Jupiter's major moons, the Galilean satellites, and you might remember that the reason why we call them that is because Galileo was the first one to see them, and that was a major discovery in astronomy because that showed us that things go around other objects in the universe other than the Earth, and kind of put a nail in the coffin of the idea of the geocentric model of the universe, or the idea that the Earth is in the center of everything. So these are the 4 moons that he saw. Again, Jupiter has many more moons than that, but these are by far the 4 biggest ones. These ones are really big. All the other ones are very small in comparison. So, what we have is oceans of water covered with ice on Europa. That's what Europa looks like. And you can see all kind of the cracks in the ice. These are caused by tidal fluctuations, which basically means the same thing as what we think of as tides on Earth, that the moon's gravity and the sun's gravity kind of stretch out the water. And so because Jupiter is so big, it has a lot of gravity, and so it kind of tugs and pulls on this moon and puts a lot of cracks in the surface of this. But we're pretty sure, this is not completely proven, but we're pretty confident that there are actually oceans of water under there because of these tidal forces continuing to slosh that water around and keep it moving. And just like a river on Earth doesn't really freeze very easily, this keeps it liquid, at least on the inside, which is a pretty interesting idea, because if we could go there and try to drill down into this ice, which by the way is miles thick, so this would be very difficult, but if we could, there is a possibility that there could be some sort of life under there. All right, Ganymede. Ganymede is the largest moon in the entire solar system. It is gigantic. So we have Ganymede, Europa, Io, and Callisto. These are the ones that I want you to know. So let's try that one more time. Maybe say them with me. Europa, Callisto, Io, and Ganymede. Okay, what planet is this? Yeah, I bet you said Saturn, right? Nope, that's Jupiter. And so one of the things that I want you to know is that all of the gas giant planets actually have rings around them, and Saturn has probably the nicest ones and the most noticeable ones, but all of the outer planets actually have rings around them. They're just a little harder to see. So speaking of Saturn, our next planet up is Saturn. So one of the ways that we know most of the information that we know about Saturn is from the Cassini space mission. And you can see a picture of the Cassini orbiter right down there. And Cassini has brought us back a lot of really great shots from Saturn. So Cassini spent several years studying Saturn and also the rest of the outer solar system, but really its main focus was Saturn. 2 million commands executed, 514 gigabytes of data collected. It actually discovered 7 moons of Saturn that we didn't know about before. It traveled 2 billion miles. So yeah, a lot of great stuff coming from Cassini. So here's a few of the pictures that came back from Cassini. That's a really nice one of Saturn and its rings, and Saturn kind of casting its shadow over its rings. Great picture there from the side. You can see edge on the rings and the shadows of the rings, and you can see one of Saturn's moons going by. Another nice shot there from the side. Really beautiful shot there. Now this is This is a really nice image, one of the most famous ones that it took. And if we zoom in on that image, one of the interesting parts of it is that we can see right here with that, where that little arrow is, well, that's us. That's what Earth looks like from Saturn. Really incredible picture there. One of the first times that we've ever seen Earth like that. And actually, another interesting thing about that is that that picture was just taken in, I believe, 2013, so just a couple of years ago at the time of this recording. And one of the things about it was that NASA actually announced that they were going to take this picture and told everybody exactly what time and what day they were going to take it. So this was actually the first picture ever taken from this kind of distance where people were actually posing for this picture. Obviously, you can't see them, but people did that, and then they can kind of say, hey, I'm somewhere in that picture. I know you can't see me, but I'm there waving at the camera. So pretty cool shot. And actually, if we zoom in even closer to that picture, you can see in this bottom right corner here that you can see kind of this little knob on the side of Earth there. And you can maybe guess what that is. That is the moon right there. So you can even see the moon in that picture if you really zoom in on it. All right, so some things to know about Saturn. Saturn, again, has probably over 60 moons. Not very dense. In fact, it's the least dense planet in the solar system, and it's so not dense that it can even float in water. It's very similar in composition to Jupiter. Both Saturn and Jupiter kind of just barely missed becoming a star. It has the famous rings. These rings are made of billions of dust particles and rocks and things like that. It's mostly water and ice, and you should know about the Cassini mission and the fact that the Cassini mission did a lot of work to have us know more about that ring system and more about Saturn in general. One of the moons that I would like you to know, probably the only moon that I really want you to know about for Saturn, is the moon Titan. Titan is the largest moon of Saturn. It has a nitrogen-based atmosphere. It actually has a very similar atmosphere to what Earth had millions of years ago. And it has ice volcanoes that feed the rings. This is actually, the picture you see there is one of the great Cassini pictures, and probably one of my favorite ideas of if I were to go to any place in the solar system, I think it might be Titan and try to go to this volcano that feeds the rings of Saturn. I can just imagine the idea of a huge volcano on this moon and being able to look up into the sky and see Saturn in the sky and its rings, and being able to stand next to one of these volcanoes and watch as all these sort of gases and bits of ice and stuff like that get shot up into the sky and kind of cascade out into space and feed into the rings of Saturn. That has to be one of the most amazing sights in the solar system. So if you ask me, that's the place that I would want to take my tourist trip to. It would be Titan. All right, next up is Uranus. Yeah, okay, sorry, Uranus, I guess. I don't know. It's pronounced both ways. I know, it's kind of funny. Sorry. Anyway, Uranus is the third largest planet. It takes 84 Earth years to orbit the sun. This should not be very surprising to you. Remember that the idea, one of Kepler's laws says that the further away you are from the sun, the longer it takes you to orbit and the slower you go. Methane absorbs red and reflects blue, and Uranus is mostly made out of methane, and so that's why it appears blue, because it reflects blue and absorbs red. Uranus is actually tipped on its side, which is kind of a little difficult to understand, but basically all of the other planets spin in the same way on the same plane, or more or less on the same axis. So you could think of it like a bunch of tops spinning on the floor. But Uranus is different. Uranus kind of is flipped on its side and spins in that way. And so Uranus kind of looks more like this. And again, it has rings. So the rings kind of go up and down in the plane of the solar system instead of horizontally. And last but not least of the planets is Neptune. Neptune is the outermost planet. Orbits the sun in 165 Earth years. There it is out there. Um, it has 3 large Trojan asteroids that share Neptune's orbit. Now, Trojan asteroids are basically this idea that it has asteroids that kind of follow both behind and in front of it in its orbit. Jupiter actually has some of these too. They're basically being kind of tugged along by the planet. Now, I think Pluto has a little something to say to that because if you recall, that's actually why Pluto was kicked out of the Planet Club because it did not completely clear out its orbit. So this definition is a little bit, some people have kind of an issue with this because both Jupiter and Neptune have not completely cleared out their orbit. But I think astronauts say that it's close enough. There is almost completely cleared out its orbit, and the parts that it did not clear out, it's kind of tugging along with it. But Pluto's not very happy about that. All right, speaking of Pluto, we need to speak about the trans-Neptunian objects. So if you think about that term, first of all, it's got that Neptunian part in it. Trans basically means beyond. Okay, so these are beyond the things in our solar system that are beyond the orbit of Neptune, or trans-Neptunian objects, or TNOs for short. And here are a few of those things. You can see that they're basically things that are smaller than planets, but bigger than asteroids. Some of them even have their own moons and things like that. We've discovered several of these, and Pluto is included in this group here. And all of these things have been discovered. They were discovered by this, many of them were discovered by this person named Michael Brown, who spent a lot of his career trying to find a new planet. And he's actually the guy that's kind of responsible for the fact that Pluto is not a planet anymore. So these are objects that orbit outside of Neptune and do not fit the definition of a planet, mainly because there is so much other stuff in their orbit. And the real main reason why this guy Michael Brown said that Pluto should not be considered a planet is basically because all of these little dots that you see out here, all of these guys that are sitting out here, these objects are all almost identical to Pluto. Some of them are even a little bit bigger than Pluto, but many of them are very similar in size to Pluto, and they all kind of share a similar orbit to Pluto. So really, if we're going to call Pluto a planet, well, all of these guys are almost exactly the same as Pluto, so we would have to call all of these things planets too. And I think you would agree that that kind of takes away from the definition of what we think of as planets. Planets really need to be kind of special, unique things in our solar system that there aren't very many of them. So, and anyway, it would be kind of a pain in the butt to remember the names of all these different ones. It's a lot easier to remember just the names of the 8 planets. So that's really kind of why Pluto is not considered a planet anymore. Pluto is now demoted to a dwarf planet, but hey, remember, Pluto doesn't really care what we call it. Pluto is still the exact same object that it always was, and we have not hurt Pluto's feelings because, well, it's a big chunk of rock and it doesn't have feelings. Anyway, answer this question in your notes. You should be able to answer that now. It should be pretty easy. And there you go. So, what did we learn today? Well, we learned that gas giants are large, low-density planets composed primarily of hydrogen, helium, and methane in a gas or liquid state. We learned about Jupiter, that it's the largest planet. We learned about the Great Red Spot, which is basically a hurricane, a giant hurricane on Jupiter that's been there for probably at least 400 years that we know of. We learned about Saturn. Saturn is very low density. We learned about the Cassini space mission, and we learned about its largest moon, Titan, one of my favorite places in the solar system. We learned about Uranus, or Uranus, whatever you want to call it. Methane reflects blue, that's why it looks blue, and it's tipped on its side. And we learned about Neptune, which has a very long orbit because it's so far out there. And we learned about trans-Neptunian objects, or TNOs, which technically Pluto is one of those guys. And I will see you in class.